In this video, I will discuss a problem on linear algebra. So what we have is we have M22, which is set of all 2 by 2 matrices, and we have the subset U of M22. Okay, so this subset U contains matrices, 2 by 2 matrices, that commutes with this matrix B. Okay, so if you pick any matrix from capital U, then that matrix is going to commute with matrix B. Okay. In the first part of this problem, we have to show that U is a subspace of set of all 2 by 2 matrices. Okay. So far, we know that U is a subset. We have to show that it is a subspace. Okay. So to verify that something or some subset is a subspace, we have to show three things. First, I have to show that zero element of the vector space belongs to the subset U. Okay, so what is the zero element? Zero element of M22 is 2 by 2 zero matrix. Okay, and this commutes with B, right? Because if you multiply uh, the zero matrix with B, you get zero matrix. Okay, so what can I say? 0 0 0 0 times B is equal to B times 0 0 0 0 is equal to 0 0 0 0. So these two are equal. So zero matrix commutes with B. Okay. So what can I claim? So the zero matrix belongs to U. That is first part. Next, I have to show that the subspace is closed under addition. Okay, so for that, I will pick two matrices from the subset U. Let A1 and A2 are two matrices of this subset. Then what happens? If A1, A2 are in the subset, then both of them should commute with B. Okay, then I can say A1B is equal to BA1 and A2B is equal to BA2. Okay, so both of them are going to commute with B. Right, so then let's see what happens to A1 plus A2 times B. Okay, by the distributive property, I can rewrite this matrix multiplication in this way: A1B plus A2B, but both A1 and A2 commute with B. Okay, so A1B is equal to BA1 and A2B is equal to BA2, which is equal to B times A1 plus A2. Okay, so what I proved was I showed that A1 plus A2 commutes with B. So therefore, this subset is closed under addition. Then I would pick some scalar lambda. Okay, so I would pick some scalar lambda, and I have to show that lambda A or lambda times any matrix in the subset U also should also belongs to the subset U. Okay, so let lambda be any real number, and A is any matrix in this subset U. Okay, so since A belongs to U, can I say AB is equal to BA? So let's see what happens to lambda A times B, which is equal to lambda times AB, and since A belongs to U, AB is going to be equal to BA. So I have lambda BA, okay, which is equal to B times lambda A, because lambda is a scalar. So I can write this scalar with any of these two matrices. Okay, so I showed that lambda A times B is equal to B times lambda A. So What does this imply? Lambda A belongs to U. In this case, I have to write A1 plus A2 belongs to U. Okay, so U is closed under addition and scalar multiplication. Therefore, U is a subspace of M22. Okay, all right. So in the next part, I have to find a basis vectors that spans this subspace. Okay, now I verified that this is a subspace. So next, I have to identify the shape of the matrices in this subspace. Okay, so first I would consider some arbitrary matrix in M22. Let's say A, B, C, D. Okay, and if A belongs to U, then what happens? Then AB equals BA, or in other words, A commutes with B. So A is A, B, C, D, and matrix B is 1, 1, 0, minus 2. This is equal to BA 1, 1, 0, minus 2 times AB, CD. Okay, right. Next, I will evaluate these matrix products in both left and right hand sides. If I evaluate the matrix product in my left hand side, I would get A and C, and I would get A minus 2B and C minus 2D. I would get A plus C, and I would get B plus D, and I will get minus 2C, and I would get minus 2D. Okay, I will double check this matrix multiplication. So first I'll multiply these two matrices. So I get AC and I get A minus 2B and C minus 2D. And I get A plus C, B plus D, and minus 2C and minus 2D. Okay, since these two matrices are equal, I can equate each element. So what do I get? I get A equals A plus C. This gives me C equals 0. And I get A minus 2B is equal to B plus D by equating these two. So I get A minus 3B minus D equals 0. And if I equate these two, I get C equals minus 2C. Again, I am getting C equals 0. If I equate C minus 2D to minus 2D, again I am getting C equals 0. So C should be 0. And I cannot claim anything about A, B or D, but there's a relation between A, B and D. Okay. So what can I say about the matrix? Now if A commutes with matrix B, then it should look like A, B, C should be 0 and D. Okay, but I have a relation that connects A, B and D. So A minus 3B minus D equals 0. So from this I can have A equals 3B plus D. Okay, so I would write 3B plus D instead of simple A, and I have B and I have 0 and D. This is equal to, I can write this in this form, B times 3, 1, 0, 0 plus D times 1, 0, 0, 1. Okay, I can decompose this matrix into two parts, right? So once I simplify these two, I would get back this matrix, right? Because I get 3B plus D, and I get B times 1, which is B, and I get D. Okay, so if you look at these two matrices, you cannot construct the second matrix by using the first matrix, right? Because of this entry 1. Similarly, you cannot construct first matrix by using the second matrix because of this entry 1. Okay, so therefore these two matrices are linearly independent. Okay, and any matrix A in this subspace U can be written in this form. B and D can be any two real numbers. Okay, so B and D can be any two real numbers. So what is the basis for this subspace? 3 1 0 0 1 0 0 1. So if you take this basis, this spans the subspace U. Okay, I hope you understood how I completed this problem, and if you get any questions when you try to understand these steps, please mention them in the comment section. Thank you.